Hi, my name is Patrick Reagan. This video, Troubleshooting Basics Part 1, covers the CompTIA's methodology when troubleshooting problems, as well as covering other common methodologies in troubleshooting network problems. The Troubleshooting the CompTIA way is introduced early in CompTIA's network videos because troubleshooting is needed throughout other topics of the Network Plus exam. Through the Network Plus certification, you'll need to learn how to troubleshoot a wide range of problems. While your experience may have you check a couple of quick things immediately when dealing with the problems, you need to learn to use the troubleshooting methodology so that you can troubleshoot problems more efficiently and more thoroughly. CompTIA's troubleshooting methodology includes a 6-step process that allows you to frame the problem and guide you to identify and execute a solution. The 6 steps include: identify the problem, establish a theory of probable cause, test the theory to determine cause, plan, which includes establishing a plan of actions to resolve the problem, and implement the plan or solution. Verify full system functionality, and if applicable, implement preventable measures. Lastly, document findings, actions, and outcomes. A mnemonic to help you remember the steps in order would be: I enjoy taking people's video disk. Identify, establish, test, plan, verify, document. Identifying the problem is the first step. For a company, it usually starts with a phone call, an email, a help desk ticket, or an alert. It is not uncommon for users to alert you of the problem. Other problems may be identified when you're reviewing logs, receiving an automated alert, or testing applications and services. While you're identifying the problem, you'll need to gather information from log files and error messages, question the users, identify symptoms, and duplicate the problem. You may need to have the user to show you the problem. To confirm a theory or solution, you'll need to duplicate the problem. While gathering information about the problem, ask what are the chain of events or steps to duplicate the problem. You also need to determine if there are any recent changes. Problems often start when a change was made to the system. If the user says that no change to the system was done, please keep in mind that the user may not be aware that changes to the system were done, does not think the change would affect the system, or he or she did not mention the change, or may be too embarrassed to say that a change to the system may have caused the problem. When you check on what might have changed, you'll need to check if the machine was updated recently or if settings were automatically or remotely changed. For example, an organization may use a group policy object to configure a system remotely, which may affect how the machine operates. You also need to check if the environment or infrastructure has changed, such as the changes to firewalls or routes. Hopefully, your organization has a change control process where you can check for recent changes to the environment. If you verify the problem exists, you need to determine the scope of the problem. For example, does the problem happen only to the one user or multiple users? Does it affect a specific site or location? Or does the problem only affect one specific application? When looking at the problem, determine how often the problem occurs. Does it happen every time, or does it happen randomly? Random problems are much more difficult to troubleshoot since you cannot always duplicate the problem on demand. Before going to the next step, you also need to see if the problem is being caused by user error. When you watch the user duplicate the problem, you might be able to see that you're doing something wrong, such as skipping a required step or selecting the wrong options. I should mention that user errors are very common in IT. As an IT professional, you should not make fun of a user for a simple mistake. In most cases, the user just did not know, or the steps or procedures are not well documented that the user is following. Instead, you should guide them so that they can learn from their mistakes. It is possible that you can encounter multiple problems at the same time. If you determine if there are multiple problems, you need to approach one problem at a time. If it is at all possible, perform a backup of the important data that may be at risk. And before making changes, consider backing up the configuration or recording the current configuration and the related configuration changes. Hopefully, if the data is important, you're already performing regular backups of the data. The next step is to establish a theory of probable cause. You should start making a list of possible causes. Then after the list is created, start looking at the most obvious causes first, and those list items that are quick and easy to check. For example, the computer does not boot when you press the on-off button. When you make the list, your list should include the obvious such as, is the system plugged into power? You will be amazed on how many times something is not plugged or connected properly is the cause of the problem. It is also embarrassing if you're troubleshooting a computer problem and you took the entire computer apart only to find out that the computer is not plugged into an active electrical socket. During this step, be sure to check your organization's knowledge base for similar problems and use your favorite search engines such as Google or Bing or AI chat such as ChatGPT or Copilot, and to search for similar problems including any displayed errors. The third step is to test the theory. It is during this step you determine the cause of the problem. You can see if the machine or device is actually plugged in, or you may need to replace a component with a known good component to see if the problem goes away. For example, if you suspect that memory is bad, you'll remove the suspected memory and install verified working memory. You'll then turn on the machine to see if the machine boots properly. If your theory is not confirmed, establish a new theory by going back to step 2 and look at the next probable cause of the problem. Mature organizations will often have a change control process that you may need to follow if you're making system-wide changes or changes that could affect more than one person. Therefore, you may need to submit the changes for approval, have the changes reviewed to ensure that these changes will not cause additional problems or bigger problems, and have the change approved before you make the change. For step 4, you have to establish a plan of action to resolve the problem and implement the solution. If you find the system was not plugged in and you plugged it in and it is working, there's not much more for you to do in implementing a fix. If the memory is the problem, which you replace with known good memory, you will need to establish a plan that will use this known good memory going forward, or do you need to order replacement memory? In other words, you're trying to establish a plan for the permanent or long-term solution and you're implementing the solution. You may need to refer to the vendor's instructions or documentation for guidance. After you've implemented the solution, you need to verify that the problem is fixed, no other problems have been introduced, and the system or systems is fully functional. If the user has reported the problem, you can verify with the user that the problem is fixed. You may need to consider preventing future issues by taking steps to prevent the issue from happening again. For example, apply system updates, patches, or firmware upgrades. Educate users on best practices, and adjust policies or configuration if needed. Lastly, you need to document the findings, actions, and outcomes. If you had a ticket system, you should document your findings in the ticket. If this was a unique problem, you should consider adding the problem and its solutions to your knowledge base. Let's look at an example. Users cannot access the internet. A user reports that he or she cannot access the internet. Step 1, identify the problem. Gather information, ask the user what exactly isn't working. Check if the issue has affected just one user or multiple users. Ask, did anything change before the issue started? Duplicate the issue. Try loading a web page on the user's computer with a browser. Did the user get an error? If so, what was the error? Can the user load any other site? Check local sites and check other internet websites. Finding so far, the user's computer cannot reach websites using a browser. It is confirmed it is all websites. Other users have internet access, meaning the issue is isolated to one device. As far as the user knows, nothing has changed. The error says the site can't be reached. Step 2, establish a theory of probable cause. Consider possible reasons. Make sure the cable is connected properly and you have a green network lights on the network adapter. Physical connection issue such as bad cable, cable not connected properly, or disconnected Wi-Fi. Check for IP configuration issues such as wrong IP, DNS, or gateway. Check firewall or security settings that may block access. Check for a faulty network adapter. Check for driver issues. Hypothesis. Check the obvious. Make sure the cable is connected properly and you have a green network light on the network adapter. Notes. Your list of possible reasons in the hypothesis that you choose may differ from someone else's probable list of causes in the hypothesis. Step 3. Tested theory to determine cause. Physically check the back of the computer to ensure the cable is connected properly and the network connection shows green lights, which indicate network connectivity. Disconnect the cable and reconnect the cable. Findings. The cable seems to be connected properly, and unplugging it and reconnecting the cable did not fix the problem. No green lights on the network adapter. Need to go back to step 2 and try another hypothesis. Go back to the original list of probable causes. Hypothesis. The user's computer may have a bad IP configuration, such as wrong IP, subnet, or DNS. Step 3. Tested theory to determine cause. You'll check the network connections, run ipconfig/all in Windows, or ifconfig for Linux and Mac OS. Look for an incorrect or missing IP address. Ensure you're pointing to an active DNS server. Ensure you have the correct default gateway. Findings. The user has an APIPA address 169.254, meaning it failed to get a valid IP from DHCP. Test DHCP connectivity by running the ipconfig/release and ipconfig/renew by checking if the DHCP server is reachable. Result: failed to obtain a new IP address. Possible DHCP issue or bad network configuration. If it is an IP configuration problem, you need to go back to step 2 and try another hypothesis to narrow it down even more and find solution. Again, go back to the original list of possible causes. Hypothesis. Check for driver issue. To test the theory to determine cause, check the device manager in Windows to see if the problem with the device. Update the network driver. Findings. No problem seen in the device manager. You update the driver and you now get the correct IP address from the DHCP server. Step 4. Establish a plan of action and implement a solution. Possible fixes: update the driver. Action taken. Since updating the network drivers fixed the problem, there's no plan of action or solution to implement. Step 5. Verify full system functionality. Check if the issue is resolved. Ran ipconfig/all and a valid IP address is assigned. User successfully browses the internet and can ping local and remote servers. Ask the user to test by opening multiple websites and check email and other applications. Step 6. Document findings and actions. What was the cause? The network adapter had a driver issue preventing the PC from obtaining an IP address from DHCP. What was the solution? Updating the network driver, resolving the issue. Next steps. Log the issue in the help desk system for future reference. Note the troubleshooting steps for other technicians. Question. A user has opened a ticket about the computer that randomly reboots. Which of the following troubleshooting steps would you perform first? Answer. Inquire about possible changes. The first step in troubleshooting is to identify the problem, which includes identify changes done by the user and by the organization, and determine the extent of the problem. Question. You have been troubleshooting a failing application for several users, and you have been learned that the application had to be reconfigured to fix the problem. What should you do next? Answer. Write a knowledge base article. You have determined the cause of the problem and how to fix the problem. You have verified that the problem has been fixed. The last step is to document the problem, including creating a knowledge base article if this information will be useful in the future. Question: you are troubleshooting a problem and you made a list of possible causes. You figured you'll check the obvious first, including to make sure the computer is connected properly. If the computer is connected properly, what should you do next? Answer: go back to your list of possible causes and choose the next possible cause to test. You will not always figure out problems the first time. This is the reason the methodology is used to make sure the troubleshooting is more efficient. Therefore, if you do not get it right the first time, go back to the list. Question: which of the following steps of the troubleshooting methodology should a technician take to confirm a theory? Answer: duplicate the problem. Question: you're assisting a user who cannot access network resources when the workstation is connected to a VoIP phone. You identify the phone as faulty and replace it. According to troubleshooting methodology, which of the following should the technician do next? Answer: verify functionality. Question: a user reports intermittent performance issues on a segment of the network. According to the troubleshooting methodology, which of the following steps should the technician do next after collecting initial information from the customer? Answer: duplicate the problem if possible. Question: you're checking to see if anything has changed. Which of the following steps of the troubleshooting methodology is involved? Answer: identify the problem. Question: you're checking to see if anything has changed. Which of the following steps of the troubleshooting methodology is involved? Answer: identify the problem. For more information, revert to these sites. In summary, you need to learn to use troubleshooting methodology so that you can troubleshoot problems more efficiently and more thoroughly. CompTIA's troubleshooting methodology includes a 6-step process that allows you to frame the problem and guide you to identify and execute a solution. The 6 steps include: identify the problem, establish a theory of probable cause, test the theory to determine cause, plan, to establish a plan of actions to resolve the problem and implement the solution, verify full system functionality if applicable, implement preventable measures, and document findings, actions, and outcomes. Thank you for watching this video. The next video will be Network Concepts, Troubleshooting Basics Part 2. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.